So what's the difference between a vapour and a gas? Now, this difference is defined by a value called the critical temperature, where a vapour is a substance in the gas phase at or below its critical temperature. And the critical temperature is the temperature above which the application of pressure alone to the gas phase will not result in liquefaction. So you can't convert the gas to a liquid by the application of pressure alone. The critical pressure is the minimum pressure required at the critical temperature to convert a vapour into liquid. The triple point of a substance is a unique combination of pressure and temperature at which three phases of the substance can exist in equilibrium with one another. And critical temperature and pressure is relevant to how we store medical gases. Just for a couple of examples, the critical temperature of water is 373.9 degrees C. For oxygen, it's minus 118.6 degrees C. So above that temperature, oxygen can only exist as a gas, which means that even under high pressure in medical gas cylinders, it exists as a gas, not as a liquid-vapor combo. Now, phase diagrams can demonstrate the interaction of pressure and temperature on phase shifts of a substance. So there will be a range of pressure and temperature at which a substance can only exist as a solid. So this is at very low temperatures. As the temperature and pressure rise, if there's adequate pressure, it can still exist as a solid, but then there'll be a set of pressure and temperatures at which it shifts to the liquid phase. So if you take this solid molecule and you increase the temperature at the same pressure, it shifts to a liquid phase. And then at the same temperature, by the release of pressure, you can shift the liquid to the vapor phase. The triple point is where these three phases exist in equilibrium. Now, if we continue to increase the temperature, eventually you will reach the critical temperature of the substance, which corresponds to a critical pressure. Now, at temperatures above the critical temperature, the substance can only exist as a gas. So the application of increasing pressure will not see the substance converted to the liquid phase. However, at a temperature below the critical temperature, a substance in the vapor phase can be converted into the liquid phase purely by the application of pressure alone.